I'm Liz Goldsmith with TIA's Single Pair Ethernet Consortium, and I'm here today with Valerie Maguire, Distinguished Engineer with Siemon. Valerie, could you tell us a little bit about your involvement with Single Pair Ethernet?
Yeah, absolutely. Hi, thanks for having me, Liz. I'm very glad to be here. As many of your listeners know, I've been involved with TIA, the organization that's currently developing requirements for the cabling infrastructure that will support SPE Single Pair Ethernet for many years now. Because we have such a strong vision for the future integration of all building devices, Siemon supported my volunteering to act as chief editor for the recently published IEEE 802.3 CG amendment. And this project defines the physical layer specifications for 10 megabit per second operation over a single balanced pair of conductors. Moving forward, I've also volunteered to assist with editing the new IEEE 802.3 DA project, which aims to develop enhancements for 10 megabit per second SPE operation over single balanced pair multi-drop segments.
Great. One of the key topics I'd like to explore in this podcast is the benefit of supporting operational technology with Single Pair Ethernet. Can you tell us more about that?
Yeah, absolutely. So operational technology, or OT, is commonly used for monitoring and controlling simple, low-speed devices that are used in manufacturing, industrial, and utility applications. Typical OT examples would be building control systems. HVAC comes to mind. Control systems that communicate with meters, sensors, actuators, and remote controllers, as well as automated industrial systems such as devices and machinery that supports manufacturing. Traditionally, these devices are controlled with proprietary or independent protocols and cables like RS-432 or RS-485. And Single Pair Ethernet as a common communication platform for OT systems would offer many advantages over these proprietary systems. Advantages including reduced cost, operation over distances greater than 100 meters, delivery of DC power, as well as potential compatibility with traditional 4-pair cables and connectivity. And all these things make it a very attractive alternative to traditional field bus communication protocols.
What do you mean by connectivity with, what do you mean by compatibility with traditional 4-pair? All right, I'll have to edit that out. What do you mean by compatibility with traditional 4-pair cables and connectivity?
Yeah, Liz, that's a good question, and it's an important point to investigate further. Most of the folks listening to this podcast are intimately familiar with what an information technology or IT network is. These networks are generically referred to as base T networks, and they operate over 4-pair TIA and ISO IEC standardized cabling, such as the familiar Category 6A media. 4-pair base T Ethernet, their chipsets won't inherently be compatible with base T1 single pair type chipsets. Therefore, it's anticipated that some type of media converter will be a necessary component to support plug-and-play interoperability between OT and IT systems and devices. In this way, traditionally independent and isolated BAS and other operational systems that are already present in the enterprise environment can be easily integrated into the IT network to support Internet of Things and building Internet of Things communication. So basically, from a 10,000-foot view here, our goal is that any device on the IT-OT converged network can be accessed and instructed to react in a certain way based upon the status of any other device in the building ecosystem.
That's an interesting development. The IEEE 802.3 CG standard amendment that specifies 10 base T1L for operation over 1,000 meters was published last year. Is there anything new in the works?
Liz, absolutely. As a matter of fact, there's some very new, exciting stuff. In the introduction to this podcast, I mentioned that earlier this year, a new IEEE 802.3 task force was formed to investigate enhancements of the 10 megabit per second single pair Ethernet protocol when operation is over what is called a multi-drop segment. A multi-drop segment, which is sometimes referred to as a mixing segment, it's different from the traditional channel topology that our listeners are familiar with, in that a mixing segment supports operation of two or more devices, sometimes these are called nodes, from one controller or switch port. So you can think of this as a sort of Ethernet networked field bus implementation, for example. And the expectation is that future multi-drop applications might include elevator control connected through multiple stories in a building, or ultra low voltage lighting, dolly lighting comes to mind, for example, or lighting control in building automation systems or small areas such as private offices, conference rooms, hallways, bathrooms or stairwells. Definitely one of the challenges of multi-drop operation that's expected to be clarified through the work of this task force is delivery of DC power over data lines. That's the quote, poodle power that you may have heard about. In this kind of situation, we need to be able to define how this power is delivered to all of the devices on the mixing segment, as well as how power delivery will be handled if one of the devices fails or is removed from the mixing segment. So you can kind of think of this as the same challenge we used to face when one of the lights on our Christmas tree would fail and the whole string of lights would go dark. So obviously that's definitely not something that we can tolerate with critical OT multi-drop applications. So we're anticipating this amendment to publish in the later half of 2023. And as one of the amendment project editors, I'll be closely involved with this project, and I feel that this is definitely one to keep an eye on.
Thank you. That sounds really interesting. A very interesting development for sure. How do you recommend that listeners stay on top of single pair Ethernet developments?
Yeah, definitely. This is activity that the listeners need to monitor. So to start, the TIA and the ISO-IC organizations that develop telecommunications infrastructure specifications, they haven't yet finalized their single pair Ethernet cabling specifications. So the listeners need to watch for updates from these two groups for sure. One of the goals of the Ethernet Alliance is to bring OT experts in building and industrial automation together with IT experts across the Ethernet ecosystem so that the two groups can better understand each other. So I would definitely also recommend monitoring the activity of the Ethernet Alliance at www.ethernetalliance.org. And finally, TIA's Single Pair Ethernet Consortium, it's commonly referred to by its acronym SPEC, which spells out spec, is chartered with accelerating the adoption of next generation OT and IT and the generation and adoption of the connectivity using these single pair Ethernet technologies. And more information from that group can be found at www.spec.tiaonline.org.
Yes, thank you, Valerie. And one thing that listeners will be interested in is that TIA SPEC has recently signed a memorandum of understanding to work more closely with the Ethernet Alliance because we see that our causes are very closely aligned. So you'll be seeing more joint announcements from the groups as we work together to bring the technology into fruition.
I'm looking forward to hearing more, Liz.
Well, thank you so much for speaking to us today, and thanks to the listeners. Please check back on our website. As Valerie mentioned, it's www.spec.tiaonline.org. Thanks very much.
Thanks for having me, Liz.